which include high resolution reflection with cube map and using high precision vertex normal and high precision vertex basis for the your static mesh. So where you set that and what that means. And for the last thing, how to turn on clear per second normal and why that's cool. And when we were done, we'll take a look at the automotive material package. So first of all, I would like to jump onto our McLaren car configurator. So a bit of a background of this project is that this project was done as a partnership between Epic Games and McLaren. Together, we were able to overcome several challenges to real-time photorealism, adding more power to the Unreal's rendering engine and providing a boost to all those working in real-time product loop development. So this is a look at our approach to the configurator. So we went to McLaren to acquire reference from a real-world car. So this includes all the material samples for the surface of the car, taken from the photograph and then from the physical samples provided by a dealership. So we received access to the paint chip, as you can see on the left side of the screen. Also fabric samples, which is on the right side of the screen here. And then finished the car paint on the surface of the sphere, which is the blue one here, which was perfect for the testing the surface material in the multiple lighting scenarios. Also the black sphere beside of the blue sphere here was used for the testing the character for the clear code. So on the top left side of the screen, this is a setup of our reference shoot. So we used the 18% of the gray car and color checker, and this little board is a chrome board, and then here is a gray board. So it is very important to get accurately calibrated reference image that we can reproduce in the engine. So we are then able to recreate each material within UE4, allowing us to recreate the car entirely within the engine. So now let's take a look at the McLaren configurator. So cars comes in. So the configurator is interactive, so I can change the color of the car. And I can open the door of the car. Turn on the headlight, and then open the hood. So as you can see, outside of the car, we can see it's the primary outer surfaces, including various variety of the metal and carbon fiber and awesome looking metallic paint with a clear coat on top. So we'll take a look at how that was created shortly. Let me go inside of the car. Actually, let me close the hood, then go inside the car. So inside, we can see the various surface type of the car's interior, including various plastic, fabric, and the synthetic material called Alcantara, which you can see on the dashboard right now. So many of these surface materials are available for free within our automotive material pack, which we will take a look at a bit later. Now let me go outside of the car, close the door. Also, the special about this configurator also show off the exquisite engineering of the McLaren. So showcasing every single nut and bolt. The entire car is about 9 million polygons, all running in real time within our Unreal Engine. So let me play the cinematic for you guys. I can still change the color of the car proactively. So in the beginning of the project, we ran into some technical challenges. So UE4 was already powerful enough to render CAD engineering data, but due to necessary simplification of the game engine, it proved difficult to get the sharp, crispy reflection that defines the line and the curve of the precision of the surface, such as an automobile. So digging into this problem, we were able to identify the key problem areas. The first was that when we imported the mesh into the UE4, the engine automatically optimized it for the efficient game use. This prompted us to add a setting to remove all those limitations and to let the engine to render full precision of the mesh information. But then that was only half of the problem. So the cube map, which was the basis for the reflected image, was also reduced in resolution as a game optimization. So this was also changed, allowing for the much higher resolution cube map and thereby allowing higher resolution reflection across the surface. So let me start the cinematic here, and I prepared some image for you guys to show what clear view of what I mean. So as you can see, before we having those kinds of settings, so you can see that reflection on the car is not clear enough. So after we have all the features, now we can have this beautiful sharp and crisp reflection on the car surface. So now let's have a look exactly where you make the change in the Unreal Engine. So start with high quality reflection. So as I described, this car has not clear reflection of the surface of the car. So what you want to do is you only go to the project setting and looking for the engine side, there's a rendering section. You click that and you go to on the texture and use the reflection capture resolution. So this means that this reflection capture resolution is which adjusts the resolution of the HDRI cube maps that are used for the reflection capture actors. So this is set to default as a 128. Now let me just move this car a little bit so that you can see the change of the reflection. Now let's crank it up to the 1024. So also we will go to the scene world outliner and look for the skylight. And you can see this cube map resolution is also set to 128. You want it to set to 1024 as well. So keep in mind that all this resolution must be power 2. So this cube map setting defines the resolution of the image of each of the 6 sides of the cube map, essentially wrapping our scene in the 6K image. So as you can see, the reflection immediately gets much sharper. So of course, you might be asking, why not just leave this set to our 1024 all the time? But the answer is that this great reflection comes at a performance trade-off, which means we are now using 384 times as much data for those cube maps. So that's a lot of work for your GPU memories and the processor. But now you get to have this great reflection on the car. Whether or not you choose to use this setting will dictate the class of the hardware your project requires. So now reflection looks great, but then the line across the surface of the hood is not sharp enough. So this is because of the mesh vertex normal encoding in our scene are optimized for the game performance as well. So to fix this, we will tell Unreal Engine to use high precision normal encoding. So in order to do that, again go to the edit and project setting. In the left section of the engine, you will find rendering again. And all the way in the bottom, you will see the optimization section, and then you will find the G buffer format. So it is set to default right now. So this means this is simplifies the data of the mesh normal to something more efficient. So but still with enough data to look good on most of the game models. But now let's set to the high precision normal, which will encode a normal 16-bit per channel now. So using this higher precision encoding will allow technique like screen space reflection to rely on the high precision normals. So but as before, it comes at the cost of using more GPU memories. So there is one more step required to sharpen our reflection, is that tell the mesh to use non-optimized set of normal and tangent. So you can think of a normal and tangent as a set of vertex coordinates that define the direction of the surface is flowing. So when you use optimized normal and tangent, a very high density mesh may lead nearest vertex together, quantizing to the same vertex normal and tangent values, which means that this can lead a blocky jump in normal orientation. So as before, these are simplified for the in-game efficiency. So, but we can optionally choose high precision encode normal and tangent as a 16-bit per channel vectors. So we will demonstrate this using this code. So what you want to do is open up the static mesh editor. And in the static mesh editor, you will find the detail window. There's LOD0 section. You just go down and then you will find the build setting. Extend that, and then on the bottom, you will see huge high precision tangent basis. You just check that off and then apply.